I like to do is I like to have my warm-ups not based on what we're going to do today, old stuff.
Yeah. All right. So here are trigonometry notes. You can go ahead and write this down in your spiral notebooks. So what do we use trig for? We use trig to find a missing side when we have information about a side and an angle, which is different than when we use Pythagorean theorem, because Pythagorean theorem we would have two sides given and we're going to find a third. Okay. So there are three trig ratios that we will talk about. They are sine, cosine, and tangent. And so here are your kind of ratios. The sine function is your opposite over your hypotenuse. So whatever information is on the opposite side, given your reference angle, divided by your hypotenuse. Your cosine is your adjacent over your hypotenuse, and your tangent is your opposite over the adjacent. And so that's why it's important to be able to label the right triangle carefully. And so if we looked here, I have my triangle. All three of these triangles are the same. They have the same reference angle of 53, but what differs is what information is given. So in the first one under sine, you would be given an opposite side and the hypotenuse side. On the cosine, you would be given information on the adjacent and the hypotenuse. And then on the tangent, you would be given information on the opposite and the adjacent. Now, there's a trick to help us remember these trig ratios and what goes with which, like opposite, adjacent, hypotenuse. So if we remember this saying, I know it's going to sound funny, it's called SOHCAHTOA. And so remember how to spell that and how to say it. So S-O-H, CAH, C-A-H, TOA, T-O-A. And so what that stands for is sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So if you remember SOHCAHTOA, you will know which two pieces go with which trig ratio. Okay. Alright, so in order to solve these problems, you will have to use the Desmos calculator. And so we have to make sure that the calculator will be in degree mode. So I want everybody to kind of take a second and open up the Desmos calculator in another window so you can practice being able to put this calculator in degree mode. Because if you don't put it in degree mode, which is not its standard setting, you always get the answer incorrect. Okay, so take a second, open up Desmos, and kind of do a split screen. Alright, so here's Desmos opened up in a split screen. If we wanted to find where to go for degree mode, what I want you to do is hit on this little wrench up here, which says graph settings. And then down here at the bottom, see it's radians that's highlighted, but we want degrees to be highlighted. And so once that's done, you're good, and you can hit the wrench again to close out of it. Every time you open Desmos, you will have to put it in degree mode. Alright, so let's do some practice problems. So, first of all, we have example 1. So you can go ahead and copy this down in your spiral. So we want to find x. And we know we have a right triangle. We have an angle, we have a side, and we're looking for another side. So this should clue us in that we should be using trig. So what I want to first do is go ahead and label the triangle based off of the opposite adjacent hypotenuse. So I already know that this side here is the hypotenuse because it's across from the right angle. And then from the 34 degrees, I know that this side is the opposite. And I know that the side with the X on it is the adjacent. So before we get started, just make sure you go ahead and label the triangle. Now, because we already have all of that labeled, we have information on the hypotenuse and we have information, even though we're looking for x, that's still information on the adjacent. So right now, we're not going to worry about the hypotenuse. So we can the opposite. We're going to ignore that. So right now, we have an adjacent and a hypotenuse. So if you remember, our SOHCAHTOA and we have information on the adjacent and the hypotenuse, so that tells us we need to be setting up a cosine problem. So that's how we're going to set this up. So now we write everything down. We want to do cosine of the angle. So the angle is 34 degrees. So we're going to say cosine of 34 degrees is equal to, now we know it's adjacent over hypotenuse. So the adjacent is the x. So what's on the adjacent side? Over the hypotenuse, which is 19. Okay. All right, so then what are we going to do now? Now we need to actually figure out what the cosine of 34 is. That is actually just a number, and we just need to figure out its value. So this is where our Desmos comes into play. So kind of come over to Desmo, and we can pull up the keyboard. And now we just want to put in the cosine of 34. So now cosine is going to be under functions. So make sure you're hitting functions. And then here it is for cosines, the COS. So we got the cosine of 34. Okay, so now we know that is roughly about 0.83. Okay, so then we come back to our problem. We know that the cosine of 34 is 0.83, and that is equal to x over 19. So now this is just an equation we need to solve. So we need to solve for x. So now we're going to multiply by 19 on both sides. Okay, so here, the 19's cancel. We're left with x is equal to, and now we're just going to do 19 times point. So we'll do 19 times 0.83. And we get 15.77. And if we round to the nearest tenth, we can get 15.8. So here we have 15.8 is x. So that's our answer here. So now we know that the x value, that length side, the adjacent side of that triangle, is 15.8 units long. Okay, let's try another example. So in example 2, we want to solve for x. So before we even get started, let's make sure we're labeling our adjacent, hypotenuse, and all that good stuff. So here, I'll always like to do the hypotenuse first. I found my right angle, come across, so I know this is the hypotenuse. I know from the 64, since that's our reference angle, this comes across, so this is our opposite. And then this must be our adjacent. Okay, now I have information on the hypotenuse. I have what we're looking for is the opposite, so I don't need the A, so I'm going to kind of ignore it for right now. So right now we have an O and an H. So we remember we write our SOHCAHTOA out. So SOH, CAH, TOA. I'm sorry, the pen is not working. Okay, so now we know we have an O and an H, so we're going to be using sine. So let's go ahead and set our ratio up. So we have the sine of 64 degrees is equal to the opposite, which on the opposite side is x, over the hypotenuse, which is 20. And so now we just need to figure out what the sine of 64 is. And remember, sine of 64 is just a number. So let's go over to Desmos, because we've already put it in degree mode. Let's hit functions, and let's pull up sine of 64. And we get that as about 0.9 when we round it. So then we have 0.9 is equal to x divided by 20. So now we need to solve both sides for x. So that means we need to multiply both sides by 20. And so now we can come back to Desmos, and we can do 20 times 0.9, which we get 18. So now we know that 18 is equal to x. And so that opposite side is 18 units long. All right, let's try example 3. All right, let's try example 3. So we still want to solve for x. So let's make sure we go and we label. And we know this 20 side is going to be our hypotenuse because it's across from the right angle. And then here's our reference angle of 28 degrees. So over here would be our opposite. And then here would be our adjacent. So we have a number on the hypotenuse. We got the x on the adjacent. So we aren't going to use the opposite here. Remember our saying, we have so, ka, oops, shrinking. All right, that's better. All right, so we know we have an adjacent and a hypotenuse, so we need to use the cosine. So let's go ahead and set up our trig ratio. We know we need to use cosine. Alright, so we know we have the cosine of 28 equals the adjacent over the hypotenuse, so we have x over 20. So now we're going to go over to Desmos, and we're going to figure out what the cosine of 28 is. So we're going to go to functions, cosine 28, and we know that is 0.88. So we're going to come back to our problem. So cosine of 28 is just a number. 0.88 equals x divided by 20. And now let's go ahead and solve for x. So we're going to multiply both sides by 20. And then go to Desmos. We have 20 times 0.88. Oops. Which is 17.6. So we come over here. You know that 17.6 roughly is equal to x. Alright, so let's try example 4. So in example 4, we're trying to find x, so we're going to make sure we go ahead and label our hypotenuse, our opposite, and our adjacent. Alright, so we have our hypotenuse, adjacent, and opposite marked. And now we need to figure out which trig ratio we're going to use. So we have information on the opposite. We have the x on the adjacent. So we know we do not need the hypotenuse. So we got an opposite and adjacent. So we're looking at tangent. So we're going to do the tangent of 73 degrees is equal to the opposite, which is 14 over the adjacent, which is x. And hopefully when you're doing this one, something looks a little different than the other three that we've been doing, but we're going to keep going. So now we need to go find the tangent of 73 degrees. So go to Desmos, go to functions, then we're going to do tan of 73, and we get 3.27. So we come back to our, so we know that 3.27 is equal to 14 over x. Now usually what we've been doing is multiplying both sides by the denominator, which has been a number, but in this case the denominator is x. We're still going to multiply both sides by the denominator. That's how we're going to clear the fraction. But this time we're left with 3.27 x is equal to 14. And now we still have to solve for x. So now that we have a one-step equation, we're going to divide by 3.27 on both sides. And now once we do that, we can put those values into the Desmos calculator. So we can do 14 divided by 3.27, and we get about 4.3. So then we know that x is equal to 4.3. Okay, so it does make a difference a little if x is in the numerator or denominator, and we'll just go ahead and solve it accordingly. And we have one more example. Alright, so now in example 5, we're looking for x. I went ahead and labeled our opposite, adjacent, and hypotenuse. And so we have information on the opposite, we have information on the hypotenuse, and we have nothing on the adjacent. So we're going to ignore that. So now we're concerned with opposite and hypotenuse, and that is sine. So we're going to go ahead and set up our ratio. The sine of the angle, which is 52 degrees, is equal to the opposite, which is 12, over the hypotenuse, which is x. Okay, so same thing. Let's go find the sine of 52. Let's use our calculator. So we got the sine of 52. And in this case, it's about 0.79. It's equal to 12 over x. And now we just need to solve for x. So in order to do that, we're going to multiply both sides by x. We get 0.79. X is equal to 12. And now in order to solve for x, we're going to divide both sides by 0.79. And then x is equal to, let's go to Desmos, 12 divided by 0.79. We got 15.2. Okay, so now we found x. All right, and those are our notes. So, yeah, goodbye.